All right, now on to question 4, and we're asked to sketch a graph of y equals 1 minus 2 over x take 2 on the axis below. Label the asymptotes with their equations and axis intercepts with their coordinates. All right, so there's a few things here that I need to point out, which I will when I get to it. So 3 marks, so there's a significant bit of stuff that's going on here. All right, so something over x take 2, well, what we know is here, this bottom, x take 2 can't be equal to 0, because if it is, you're dividing by 0, which is undefined. So if x take 2 can't equal 0, that means that x can't equal 2, which means that we should have a vertical asymptote at x equals 2. All right, so this form could cause a rectangular hyperbola, something over, and they've rearranged it and written it maybe in a different order than you might think, but something over with an x on the bottom, to the power of 1, rectangular hyperbola. So x can't equal 2, so there's our vertical asymptote, and it says label, so I need to put x equals 2 on that. All right, if I don't, I'm not going to get all my 3 marks. All right, the next thing here is we've got this negative in here, so instead of normally we would have them in the first quadrant here, this down here, so it's going to be flipped over, and we're going to have it down there and down there, flipped over I should say, reflected in the x-axis to be technically correct. And then we've got this 1 at the front, which is positive 1. So normally a rectangular hyperbola would have an asymptote along the x-axis, but in this case, because we've been translated up 1, we have our horizontal asymptote right through here. Now, of course, when you're doing this on the exam, you will be using your ruler to do better than what I'm doing here. All right, so there's that. So label the asymptotes, yep, and with their equations, yep, done that. All right, x equals 1, y as 2, sorry, y equals 1. And the axis intercepts with their coordinates. Okay, so now I'm going to find the axis intercepts. So I do that the same way I find all intercepts. Y-intercept when x is 0, so we've got y equals 1 minus 2 on 0 take 2. That's 1 minus 2 on negative 2. 2 negatives make it positive. Positive 1, which is 2. So our y-intercept is here at 2. Now it says axis intercepts with their coordinates, so I need to label that point with its coordinates. Now its coordinates are x equals 0, y equal 2. So our hyperbola, which we've got to draw, will go something like that, because it says sketch the graph, so I need to put that in. So there's my y-intercept, my x-intercept, y equals 0. And when I do that, 0 equals 1 minus 2 over x take 2. Do some rearranging. I'm going to add 2 over x take 2 to both sides. I'm then going to multiply both sides by x take 2. Then I'm going to add 2 to both sides. And I'll get x equals 4, which was there. And again, don't forget, label it with its coordinates. And here's our hyperbola going around there, something like that. All right, that's good. Now, I'll just point something out because I just noticed this. Notice here you've got that margin there. You notice I've gone outside that. Try not to do that because remember these are all scanned, and so anything that may be outside here, well, certainly over here, don't write in this area because that gets chopped off before it gets run in the scanner. So anything that's in here ends up in the rubbish bin. But because it's scanned, anything that you put outside this box that goes around the question, and we'll go further down here. See, there's the bottom of the box. So if you write anything down here, it might not actually get scanned. So make sure you don't do what I've done here. All right. Anyway, I'm starting to waffle on, but it was mentioned in the examiner's report that students should practice making sure that they write inside the box, because I guess there must have been instances when stuff didn't get scanned. Anyway, let's move on. So there's our graph. It's all good. And now we want to find the values of x for which 1 minus x over x take 2 is greater than or equal to 3. All right. So this graph that we've just sketched is the 1 minus x over x take 2. And so this y that they're talking about is they're talking about greater than or equal to 3 for the y. So what I'm going to do is I'm going to say, okay, what about if we just look at the equals part first? What about if I look at where 1 minus 2 on x take 2 is equal to 3? All right, and so if I rearrange, take 1 from both sides, times both sides by x take 2, expand that. Oh, actually, I can just divide by 2, can't I? And if I divide by 2, add 2, and it's at x equals 1. So at x equals 1, which is here, if we come up there, that's 3. So what I'm going to do is change my colour here. Let's go to an orange. All right, so when y is 3, which is this line across here, I'm doing this for illustrative purposes, we're looking at x equals 1. All right, up to there. All right, now let's look at the greater than part. So I've worked out where it's equal. So I've worked out the equal bit. And so now I need to work out where it's greater than 3. Now that dashed line there is where y equals 3. So that's where 1 minus 2 over x minus 1 is equal to 3. If it's greater than 3, it's going to be up here. So we're now going to infer that. So it's between -1 and up here. +1 and up here. We've got an asymptote at 2, and then if we go past 2, it's down here, so it's less than. So let me change my thing back. So the values of x are, so x will be an element of, well, 1, and 1 is included, so that's where it's equal to. And the other end is the asymptote of 2. Now, because it's an asymptote, 2 itself is not included, so we've got to put a curved bracket around that. All right, and so that is the final answer to part B. So really what I've done is I've used the graph to infer what that set of numbers or set of x values would actually be. All right, I found the equals bit, and then from the graph I've then inferred which way it goes and where the other end point is, and of course it's one that's not included.